Here's some data about Netflix updated to April 2013, at which time Netflix had a current total of 29 million subscribers, and it added 2 million subscribers uh, in the previous 2 quarters, the previous 3 month segments. And you can see some data for the this is for fall of 2012, that there are users are making 4 million ratings every day. One of the interesting features about all these fields is the users are helping the companies, because these ratings are what the companies use to make recommendations. And instead of sitting there scratching your head waiting to find data, the previous users are supplying the companies with this wealth of data, 4 million ratings of movies every day. This is something that never used to happen. We never had this type of data. And then we have actually somewhat fewer searches, 3 million a day, and the number of movies played is 30 million a day, with 2 billion hours streamed in the last quarter of 2011, and that's already increased in 1 month of summer 2012 to 1 billion hours in a month. Pretty impressive, and this is an example of today's technology companies. Here we have some fancy names for the technology. Regression, these are elastic nets, these are all approaches to machine learning. And we've a lot of things are done with matrices. We have clustering, which allows you to find which things are near each other. We have association rules and decision trees, which give you a hierarchical way of building up relationships between things. And latent Dirichlet allocation is a very famous technology invented by a brilliant young scientist, which is used for finding hidden information. And you have a collection of data, which is like documents or movies, and it will effectively group them together according to so-called latent factors. So latent factors are things which are not obvious, but can be determined based on other characteristics of the item. For the this could be the rankings of users. In the case of documents, it's often the words in a document. It could be the words in a movie, and you can then group movies together based on these this sort of rather blatant data about their makeup, and then you can use the you can try to identify what's near each other based on that, and that's what LDA does. And there are many related technologies such as semantic indexing and things like that. So there is a very famous $1 million prize given by Netflix to try to improve their rating prediction. And this comes from this website, Kaggle. I think I don't know whether this particular, I doubt if this came from, it might have come from the Kaggle website, but and this just shows that in this particular prize was given in September 10th, 2009. And this had an intermediate stage. The prize went in 2 stages, where the first stage was by a team from AT&T, which improved the algorithm by 8.4%. And they actually had an incredibly complicated algorithm with 107 different algorithms combined together, because I pointed out hybrid methods. So there are many different ways of deciding how to predict which movies people will want, and none of them is terribly good, but maybe 107 of them are pretty good, and that's what this team exploited. And here is the final prize with the 2000, this is September 2009, check for $1 million with the team that won the prize. Here's a nice comment on this general area of from this. I think I mentioned this slide earlier in the class, from the senior vice president of Walmart Global E-commerce, and he's pointed out that he taught a class, and as part of that class, he discussed rating of movies, and then he had many teams in his class, and he pointed out that some teams did what actually the winning team did, namely really improve the algorithm. But another team say, hey, there's some more data out there we're not using. And the team that did better in this Rajaраman's class was actually not the team that had the fancy algorithm and lots of mathematics. It was the team that added more data. So this is why this slide is called more data usually beats better algorithms. And that's why we talk about data mining in the fourth paradigm. Data can tell you things which are quite unexpected and can be done independent of any theoretical study. Here's some more precise statements about the recommender systems from Netflix. The ranking involves scoring and sorting and filtering a bag of movies to present that to the user, and you want to find the best possible ordering of the videos within a specific context, and this has to be done in real time. When you're shopping on Amazon or in fact on Netflix, you're not going to wait for the recommending to happen. You need to be able to know now what to buy, and so there are many actual algorithms, some of which are quite time-consuming, and those algorithms still have value. They can be used to prepare the data for the later use online in real time, but the actual recommender system that's used while the user is online has to run in fractions of a second so that you can present the results to the user immediately.